is 15, and the sample size is 23, and we are told to find mu x bar, and we are also told to find the standard error. The mu x bar is the mean of central limit theorem. So according to the definition, the mean of the central limit theorem is equal to the mean of the original data. So the mean of central limit theorem is equal to the mean of the original data. That's all we need to answer. The standard error, which is the standard deviation of the central limit theorem, is equal to standard deviation divided by square root of sample size. And standard deviation is 15 right now, divided by square root of 23. 15 divided by square root of 23, you can use your calculator to evaluate that. So 15 divided by square root of 23. Okay, so I have 15 divided by square root of 23 is the standard error. All right, so the standard error is 3.12 to 3 decimal places. The standard error is 3.128. 3.128, that is the standard error. So I have 3.128. 3.128. So we have answered that question. That question says, given the mean of the original data and the standard deviation of the original data, can you find the mean of central limit theorem and the standard deviation of central limit theorem? So it's really easy. It's as easy as that. Let me include something. Let me add something there. Okay, suppose I am told to find the area. Suppose I am. You see, this is not a raw. This is a raw data. It's not standardized because the mean is 65. The standard deviation. Suppose I include something. So let me go back to that question. Include something. So I'm going to that question and including something now. Okay, so I am going to include the fact that there could be other questions. Suppose I am told to find the probability of, in that particular question, what if I'm told to find the probability that a number, let me say, a number that is, let me go to 70, is less than or equal to x bar is less than or equal to 75. Well, the mean is 60. The mean is 65. I can actually say 60 here. That's 60 to 75. So I'm told to find the area under central limit theorem. So this question is asking me to find the area under central limit theorem. And so the mean is 65. And 60 is below the mean. And 75 is above the mean. 75 is above the mean. So I'm told to find the area between. Okay. So all I have to do, first of all, I have calculated the standard error. So this is the standard error. Okay, it's going to be the normal calculation, but this time it's going to be normal CDF, starting from, what is the lower number? 60. This is raw data. What is the upper number? 75. What is the mean? 65. What is the standard error? Not standard deviation. Standard error is 3.128. Because this is area under central limit theorem. So you will be told to find the area under central limit theorem. Whenever you are told to find the area under central limit theorem, you put it in. You can use raw data, You can standardize each of them. Standardizing each of them will take you time, but whichever way is easier for you, you can do it. If you have to use the chart, then you must standardize all of them. If you have to use the chart, you must standardize all of them. Okay, so now I am going to get my calculator and answer that question. So what is the area under the standard normal curve? So I'm going to calculate the normal CDF starting from 60, arrow, the upper number is 75. Okay, the mean of this data is not 0 because it's raw data. So it's 65. And the standard deviation, the standard error this time, because I am doing central limit theorem, so standard error is 3.128. 3.128. So this question is actually a central limit theorem question. So if you have a central limit theorem question, you must first of all calculate the standard error, because in your normal CDF, you will use standard error in place of standard deviation. You hit enter. Therefore, the area under the area between those two numbers is 94.43. That is the area, 94.43. Okay. So the same thing. So let's go back to another question that is only, if the question is only find the area under standard normal curve. Okay, let's go back and see another question on central limit theorem. Another question on central limit theorem. Here's another question on central limit theorem. Number 25. It says determine the mu x bar, the standard error from the given parameters of the population and sample size. And whenever you see mu x bar and standard deviation, then you are really talking about central limit theorem. So most questions will not tell you it is central limit theorem, but they will ask you a question that implies that you will use central limit theorem, like in this one. So this is number 25. I will just write it and solve an example. So I'm going to first of all detail what we are given in this question. So number 25. 25. We're given that the mean of this data mu is 70, and the standard deviation here is 24, and the sample size is 64. And I will include two things, or I will ask a question. So the first question is find a mu x bar, which is given to us. Find the mu x bar. The second question is B, find the standard error. And the third question is find C, find the area between the mean, find the random variable such that it starts from the mean is less than or equal to x bar, because the random variable is x bar is less than or equal to 81. In other words, find the area between 70 and 81. So what I'm going to do is I'm going to draw a picture. Draw a picture. So I'm going to draw a picture of what I'm looking for. So I'm going to clean some parts that way. I'm cleaning some of these. So then I'll draw a picture. Okay. So the first picture the picture I'm going to draw is a normal curve. So I'm going to draw a normal curve. And by the way, this normal curve I'm drawing is a density curve made with sample means. That's why it's called the distribution of sample means. Because it's distribution of sample means. The mean of this distribution of sample means is 70 given to me, because the mean of the original data is the mean, is something as the mean of, so the mu x bar is equal to 70. And I am told to find the standard error. Standard error is equal to the standard deviation of the original data divided by square root of sample size. And the standard deviation of the original data is 24 divided by square root of 64. 24 divided by square root of 64, square root of 64 is 8. 24 divided by 8 is 3. Therefore, the standard error is 3. So standard error is 3. Standard error is equal to 3. All right. Now I want to answer question C. So the question C says find the area between 70, and 70 is the mean. Find the area between 70 and 81. So this area is on the right side of the mean. Find the area between this. So I am going to fit this in my calculator. It's easier to do with calculator because it's a raw data. But you can as well, suppose you're told to do it with chart. You can read the chart. Okay, so normal cumulative density function. I have to write the argument first. The upper bound, the lower bound, the mu x bar, which is the same as the mean, and the standard error. So be careful. Whenever you're told to find the area under the central limit theorem, you are using the standard error. Whenever you're told to find area under the central limit theorem, you will use the mu x bar and the standard error. The only thing new there is standard error, because actually the mu x bar is the same as the mean of the original data. So there will be no change. But anyway, there is going to be a change with standard deviation. Okay, so I'm about to answer question C. So let's answer question C. So question C says, so find the area between 70 and 80, normal cumulative density function, starting from 70, ending at 81. The mean is 70. The standard deviation is 3. Remember that standard deviation was 64 before, but standard deviation is 3 now, because I am using the standard deviation of the mean of means. So I'm going to calculate. So I pull my calculator up and I will calculate what is the lower bound, second distribution. What's the lower bound? Number 2. So that is 70. What is the upper bound? Upper bound is 81. What is the mean? The mean is 70. What is the standard deviation? The standard error this time. The standard error is 3. So I can paste. And it's asking me, is that what you want? That's the argument I'm looking for. So that is the argument that I want. When I hit enter, the area is 49.99%, approximately 0.5. So the area is 49.99%. That's the area between 70 and 81. Okay. I hope that is clear. That is really, has to be clear. Okay, we will also review it when we come back from spring break. Meanwhile, we want to go back to now we're going into practice tests. We are now reviewing. So we are now in review mode, okay, for Unit 3 test. Review mode for Unit 3 test. I'm going to be cleaning up a little bit. So let's do some cleaning. The area on the left and right. On the left, okay, on the left of z equal to 1. Let's see, make sure that I'm writing the question. Okay, z equal to, okay, the first one says on the left of z equal to -1. Okay, on the left of z equal to -1, this is left, z equal to -1, and on the right, RIGHT, of z equal to 1. So you draw a picture. First thing you want to do is draw a picture. So I'm going to draw a picture. So this is z equal to 1 here, and z equal to -1 here. You know, we can find this with central limit with the empirical rule, because the empirical rule says that we're actually looking for area to the right and area to the left. And these two areas will be equal. But guess what? We know that area under the normal curve is 1. So all we have to do is 1 minus 68% according to empirical rule. Okay, so, and when we subtract, we have 32, approximately 0.32, 0.32 approximately is the sum of these two areas. And if I'm told to find each area, I'll divide by 2. This is not even a big deal. So 0.16. So area on the left-hand side is 0.16. So there are so many ways we can do it. We don't want to do it the long way. The long way is using a calculator. We can do this the short way. So this is the short way. And by the way, normal curve is symmetrical. Therefore, if I find the absolute value of -1 is 1. If I find the absolute value of 1 is 1. So since normal curve is symmetrical, area to the left of -1 is equal to area to the right of -1. So I can actually say that area is, okay, for z plus or minus 1 is equal to, let me clear this first. Okay, so if I'm looking for that area, is equal to plus or minus whatever I have in that area, 0.16. So plus or minus 1, so 0.16. So the area to the left is 0.16, area to the right is 0.16. The normal curve is symmetrical. The normal curve is symmetrical. Okay, so that's an example of a question in normal curve only. Question in normal curve. The next thing is B. Find the area under the normal curve to the left of this. So all you need to do, make sure you know, and this time we can actually use our chart. I'm going to pull up the chart. So let's use a chart, because you are allowed to use your chart, you are allowed to use your calculator, you are allowed to use empirical rule, whichever one you want to use. So let me get the chart now. So I'm going to use the chart to answer this question. So this is the chart, and I'm going to make it bigger, and I'm going to look for the standard z-score. This one is not z because this is t-distribution. So I'm looking for z. This is z here. Z is always looking for area to the left, the cumulative area, or the percentile. Okay, so I'm going to make this bigger from here. I'll make it bigger. All right. And this question tells me to find the area. So that question is asking me to find the area. Find the area of the normal curve to the left of negative 1.58, okay, plus the area under the normal curve to the right. So I'm going to find the area to the left from negative 1.58, and then find area to the right of, and then I will, so let me actually pull up my whiteboard, make it smaller. All right, and then I can clean up, do some cleaning. All right, I'm going to add these two areas, and I can use calculator, but let's read the chart. So you'll be free to use any one you want to use. If you are more comfortable using the chart, that's fine. Okay. So I have Z is equal to negative 1.58 plus, I'm also told to area to the left, and then plus area to the right of Z equal to 2.5. Right. Okay. All right. So I am going to draw different diagrams for this so that, I'm going to draw different diagrams for this. Okay. So I have, and then to the left of negative 1.5, negative 1.58. And find the area. And then to the right of 2.55, the shaded region. So I'm looking for two areas. When I finish, I add them together. Okay. When I'm looking for this area, I just get the cumulative area. So let me, I'll get the area to the left first. So for negative 1.55, negative 1.5. Okay, so this is negative 1.55 right here. Negative 1.5, 0, 1, 2, 3, 4, 5 right here. So I am going to, okay, so negative 1.5. And then I'm going to put that in my, I'm going to put this in my chart here. So it is, what is the number? Let me go back. Negative 1. Negative 1. Okay, point. Okay, 0, 1, 2, 3, 4, 5.0606. All right, so I have 0.0606. So this area is 0.0606. 0.0606. Okay, for this area, I can, what I'm going to do is 1 minus, this area right here is to the left. So I'm going to calculate what is, so I'm going to calculate 1 minus area to the right. If I'm finding area to the right, I can use calculator to do that. So, by the way, if I'm reading the chart, I will just pull that up when I get the answer. So this is 2.55. So I am going to look for 2.55. And when I get that area, I'll do 1 minus 2.55 So here is 2.5. Right here, 0 0.50, 2, 3, 4, 5. 0.9946. So 1 minus 0.9946. 0.9946. I'll get an answer. Approximately, that answer is going to be 0.0054. And then I'm going to add these two areas. These two, that's what they want me to do. So plus 0.0606, add them up. And this is 1, this is 6, and this is 6, and this is 0. So the total area is going to be 0.0661. So the total area will be 0.0661. So that is the area to the right plus area to the left. That's area to the right plus area to the left. So we're going to continue with this review. I just want to make sure you know that you can use the calculator. You can to do this score. You can use the empirical rule to do this score. You can also use the chart. Anyone you know how to use. By the way, if you forget the formula, then you have to use the chart.